So now that we have our wire in place, we have to wire it into the valves. And to access the wires on that fresh cut, use something sharp to cut open the sheeting on the wire so that you can pull back the outer jacketing. Then you'll find a little white string inside of all of the wires. This can help you pull down and cut open the jacketing of the wire. So the area where you cut the wire, it's important to cut back any excess wire that was at the tip of that where you cut the jacketing back. Because if you accidentally nicked a wire, that can be an issue in your system forever and ever. Water intrusion into the wires will create issues with communication. It can cause shorting and it can cause system failure. So it's important to make sure that you have clean wires. As you can see, I just cut it back to where I had used my sharp blade to cut back the jacketing. And now we have good wires that were cleanly exposed using the wire jacket cutting string. And we'll expose our white wire for the common. And we'll use the green wire and the yellow wire for this valve manifold to wire back to the controller. Then strip each one of the wires back about 3/4 of an inch to give yourself enough room to make the connection with the valve wire. Here on the valve wire, you're going to have 2 wires coming out of each solenoid. One will go to the common and one will go to the station terminal in the controller. It doesn't matter which one when you're talking about AC control. There's no polarity in AC that would cause this not to work correctly. So choose one of the wires from each of the valves, put them together, and wire them together with the white wire from your multi-strand cable. These are sometimes called the neutral wire or the common wire. If you're installing a DC or battery operated controller, you're going to need to follow the polarity on the DC latching solenoid. One's red and one's black to make sure that it operates correctly. So get all your common wires together in a bundle. Some people will pre-twist. Some people like to use the wire nut to twist. In this case, I'm going to pre-twist, and then we're going to add the wire nut onto the cable. I cut it there so that every wire is the same distance from where the coating is cut to the end of the wire connection. We're going to be using DBOB wire connectors. These are waterproof connectors from 3M. And we want to make sure that when we put the wire nut on, we have a good solid connection where all of the wires are touching and well fastened inside of the connector. Now we're going to take and we're going to wire the valve on the right to the green wire and the valve at the bottom of the screen to the left to the yellow wire. You'll see that I pre-twisted the solenoid wire as it's a multi-fiber stranded wire. I twist it to make sure that it's more of a solid connection before you twist it to the station wire going back to the controller. Again, you'll see that the insulated coating is cut back to the same length on each one, and I cut the tip off to make sure that they were consistent. Now we'll twist on the wire nut and give it a nice vigorous twist to make sure it's nice and tight on those wires. We'll grab the wire nut and try and pull the wires out to make sure that they are fastened securely in the connector. And we'll do the same thing here for the yellow wire that's going back to the controller, and that is the lower valve on the screen. So again, in conclusion, to sum that back up, one wire from each solenoid is combined together and wired onto the common wire, which is the white wire in this case, and the other wire on the solenoid goes to the station terminal in the controller. So one wire from each solenoid is together. The other wire on the solenoid goes to its own wire lead back to the controller. So now that we've double checked to make sure all of our connections are nice and tight, we have our yellow wire, our green wire, and our common wire. We'll check at the controller to make sure the communication is good, and then we'll come back and we'll add our waterproof connectors, as you see in this scene. So the blue tube is filled with a waterproofing gel that makes sure that this connection is watertight once applied and stuck all the way to the bottom of the tubing. There are little wings on the wire nut that line up to grooves inside of the connection tube. Line those up and then push that connection all the way to the bottom of the waterproofing container. If it becomes too difficult to push it down using just the wires, you can use an external source like a landscape flag or a thin piece of sturdy wire. You'll see looking in the top here that the gel has covered all of the wire and wire connection, and it's now waterproof. When you have the wires in place, close the lid, creating a tension relief to make sure that that nut does not come back out of the tubing. Make sure it snaps on both sides and creates a tension relief on the wires that will prevent those from coming back out. Repeat this step for all three of the connectors in this valve manifold. You'll see in this case that it was too difficult to push the nut all the way to the bottom with just the wires, so I've used a landscape flag to push it down the rest of the way. You don't want to use something that's too big, like a screwdriver, that will actually pull the gel back out of the tubing and render it non-waterproof. So you'll see that the nut's all the way to the bottom on both of those, and we'll repeat the process for the yellow wire. So we'll use that landscape flag again to make sure that we can get it all the way down to the bottom, creating a good waterproof seal. Snap the cap on the top, create tension relief on the wire nut. It's clicked in place, it's not coming out, and we have a good waterproof connection on all three connections here. As you can see, we got the nut all the way to the bottom on all three, and we're good to move on. You'll see here is the bleed screw on the valve. This is a way that we can manually activate the valve, as well as a quarter turn of the solenoid. Either of these options are good for manually bleeding the valve to make sure that the water is flowing properly through the system and that we are flushed on all of the lines before we put the sprinklers on. So we've tested both of them. Water flows cleanly through. They activate, they deactivate, they close and open perfectly. And we are good to put the valve box on the manifold now. So we'll bring the wiring back up to the top of the manifold here so that it is away from all of the gravel that we'll be putting in the bottom of the box. We're going to use a combination that I like that includes brick support as well as landscape fabric to prevent root intrusion and gopher or pest intrusion. And then backfilled with gravel to ensure that it has good drainage in the bottom of the valve box. Now we'll get the bricks laid, the valve box on, the gravel backfill, and your valve manifold is complete. Thanks for watching. I hope this was helpful to go through a more in-depth process of the valve manifold installation. For more information about our training and other products, visit hunterindustries.com. If you'd like more information on our training site, visit training.hunterindustries.com. Thank you.